In this question, you need to rewrite the function in vertex form by completing the square for the function f of x equals x squared minus 4x minus 3. And you can do this a couple of different ways. First, using algebra tiles, or using the algebraic method. And after both methods, we can always check graphically. And you can see that I've already started using the algebra tiles. I've set up my x squared, my negative 4x's, and a negative times a negative is going to give me positive 4 1s. So if I go to my equation here, I've got my x squared, and I've got my negative 4x's. But I need negative 3. And right here I've got 4 positives. So I'm going to put in my 4 negatives. That creates the 0 pairs. But I need it to be negative 3, so I'm going to add 3 more negatives. When I do that, I get x minus 2 times x minus 2, so x minus 2 squared, minus 7 more. And therefore I've completed the square. So I get x minus 2 squared minus 7. So the second method that we can use is the algebraic method. So the first step in the algebraic method is to move our constant away from our variables. So we're going to isolate our variables. Then we're going to say what's half of negative 4. So half of negative 4 is negative 2, and negative 2 squared is positive 4. So I'm going to add a positive 4 and a negative 4. Then I'm going to move that negative 4 to the outside of the brackets with the negative 3. This is going to create my perfect square trinomial. So therefore I get x minus 2 all squared, and the negative 3 and negative 4 create negative 7. So I've got that same answer twice now. The last thing that we need to do is to check our answer graphically. So here we can see that our a value is positive 1, our p value is positive 2, and our q value is negative 7. And when we do that, we can see that both graphs give us the exact same graph, so both equations are the exact same graph. Therefore, we must be correct.